Welcome to video number 5 about how to write a chess program in Go. So by using the compare function in VS Code, you can see that there are no important changes since the last time, but here we have one. Handle position. I have changed quite a lot in that. So if we look, this is the position command, right? If we take a look at the UCI spec, the position command have two parts. One is about the position itself, what position to set up, and the second part is about what moves we should make in that position. And the first part is either the keyword fen and something called a fen string, or start pose, and that means starting position. So one of these two, and after that the move part. This is the way to set up a position on our internal chessboard. First I tidy up the command with trim, and with the help of trim prefix we remove the position, the keyword position. We don't need that anymore. So after the split on moves we will have two parts. One part before moves, that is fen string or start pose, and one after moves, the actual moves. Two parts. Starting with the first part, I make a split on space or blank or whatever you call it into or ALT 0 or 1. Either we will get start pose only, or we will get fen and fen string. If it's start pose, I replace the keyword start pose with the fen string for starting position, the position where the where a game is starting. So if we take a look at how this fen string is built, the fen string is representing the board by using characters. For instance, R, lowercase r is a black rook, lowercase n is a black knight, uppercase is white pieces. The first row is R, N, B, rook, knight, bishop, queen, king, bishop, knight, rook, and you read this from left to right and left to right on the board as well. And every rank, every row is finished by a slash, and then comes the next row. If there is a number like 2 or 3 up to 8, it's a number of empty squares. We looked at the first row. The second row is a number of P pawns, 8 pawns, and lowercase black pawns. And after that we have 4 rows with 8, and 8 is empty squares, 8 empty squares on each row. And now we reach the white camp, and we have 8P, that's pawns, uppercase, white pawns. And after that we have rook, knight, bishop, queen, king, bishop, knight, rook. That is the whole position. Now after all these pieces you have a W or a B, and that is who is to move, and here is W, white is to move, B means black is to move. And after that we have the castling status for both sides. So we have uppercase K means that white can castle king side, Q means white can castle queen side, lowercase is black and castle, kingside and queenside. After that we have the en passant square. If white, in this case, who is to move, can make an en passant capture, that square you reach with en passant is here. But now there is no such square, so it's just a dash. The first number here is about the 50 move rule. And the 50 move rule says that if we have made no captures or no pawn moves during 50 moves, the one who is at the move, I think, can claim a draw after 50 moves without pawn moves or captures. Every time we make a pawn move or a capture, that counter is set down to 0. Otherwise it's increments by 1 after each such move that is not capture or pawn move. And the last thing to parse in this string is the actual move number, and it is always set to 1 in the starting position. And here we take, it's game moves, so it's 1 move for white and 1 move for black, and after that we increment this number. So it's white and a black move, and it's not made moves. Here we're waiting for white to make a move and black to make a move, and after that number will be 2. As I already said, if it's start pose, I replace that string start pose with the fen string. If it's not start pose, it's fen and a fen string, I just make blank, and we know that OLT1 is the fen string, so OLT0 will be nothing. After that we make the join. That was unnecessarily complicated. I will change that after this video. In fact, we could put that fen string directly into part 0. Well, I fix that later. And now when we have the fen string in the first part, we parse that fen string and set up the board. And if we have a moves part, we trim it and make it beautiful, and then we parse the moves that we have there and make them on the board. I have made these parse functions, but we have no board to work on yet. But the parse function itself, this is parse fen, and we just go through all the pieces, and instead of setting up the board we just print. I put this and that on the board or empty square. Just I have comments in the end that take care of side to move and castling and so on. So this is just a structure. And the same goes for parsing moves. We cannot make move, we have no board, but we can print that we make a move, and we will fix that later on. I have made a bunch of test cases for the UCI function, and here we do use the normal Go way of testing. So we have these struct called tests, and every test have a name if we want, and after that I tell the command to put in test and what result I want. It's called wanted here. I have been talking about to use a special tell function for testing, and everything that normally should end up to the GUI will instead end up in this slice of strings, all to GUI. And this is achieved by replacing our main tell function that we have here So we get the number of strings in and we put them together and we print that to the GUI. And the tell function is default main tell normally in the program, and our test tell will do exactly the same as main tell, but instead of printing to the GUI, we'll append it to the All-to GUI slice. In the beginning of every test we have with the UCI, we set tell to test tell. So every tell that is made after this is using test tell instead. Now, instead of getting input from the GUI, we want to create our own input during tests. So we have this channel line. We can call it input instead. So we send that channel to UCI, and we send all the commands to input. I use Go UCI here. Normally we don't use Go, we just start it. If we didn't use UCI as a Go routine here, UCI would just start as a function, and then we would stand here waiting for UCI to finish. And we don't want to do that during tests. So we start UCI as a Go routine and continue to send our commands to UCI. And that's perfectly fine, because UCI doesn't return anything and it will just work fine. So every test case has a name. We have a UCI command that we want to test, and we have the result that we want to get. We put that in wanted, and we compare wanted with what we have in All-to GUI. And almost nothing is written yet. I mean, we don't have all these commands, so most of the thing we expect is not implemented yet. But the UCI command we actually have implemented, so we expect the strings ID, name bingo, and ID author, and some options that's sensed from this command, handle UCI. So that's okay. And is ready, we expect ready OK to come back, or come to the GUI, I should say. If we make set option, for instance, set option hash, it's not implemented. So what we expect is the string info set option not implemented. The same with UCI new game, and the same with a lot of other functions here. And while we write all these functions, we will replace the wanted test. I will not talk so much about how the test is made here. I mean the code here. I just mentioned that I will do tests in the background that you will not see so much about. Let's run this test. It should work fine because I have done it before, and here we get tests passed. So let's deliberately make an error and run the test, and we will get some errors. The UCI X command doesn't exist, so all these wanted strings, they will not appear. So we get an error for each string. So we set back to UCI again, and we run the test, and everything is okay. Perfect. That's all for now. Next time we will actually set up things on the board.